Water Resources Engineering 2, Unit 1, Gravity Dam. So, in a gravity dam, the section is considered to be made up of transverse vertical elements acting as a cantilever, thereby transferring the load to the foundation. So, thus the foundation should consist of strong and durable rock. So, gravity dam can be built up to any height provided sound foundation is available. So, forces acting on the gravity dam. So, the following are the forces acting on the gravity dam, that is the water pressure, weight of dam, uplift pressure, pressure due to earthquake, wave pressure, silt pressure, ice pressure and wind pressure. So, now all these forces are discussed one by one. So, first is very important is the water pressure. So, this is major external force, or now you can say this is the major disturbing force which are acting on a gravity dam when upstream face of the dam is vertical. So, the water pressure acts horizontally. The intensity of pressure varies triangularly with a zero intensity at water surface to the value gamma W into H at a depth H below the water surface. So, the resultant force due to this external this water pressure or the water forces, that is the capital P, is equal to 1 by 2 gamma W into H square, which is acting H by 3 from the base. So, this is the value of the gamma W is taken as the 9.81 kilonewton per cubic meter. When the upstream face partly vertical and partly inclined. The resultant water force can be resolved into horizontal component, that is capital P, and the vertical component, that is the PB. So, the horizontal component P, that is the same as earlier, that is the 1 by 2 gamma W H square, which is x at h by 3 from the base, and vertical component, the PB, or now you can say here is also shown the P2, is equal to the weight of water stored in the column A, B, C, D, A and acts at the CG of area. And similarly, if there is tail water, so this tail water on the downstream side, it will have horizontal and vertical component, and that will also the act or the intensity, pressure intensity, that is the 0 at the water surface, and at the bottom or at the base this is the gamma W H dash, and so this P dash, capital P dash is equal to 1 by 2 gamma W H dash square, which is acting H dash by 3, this is the horizontal water pressure, but in vertical water pressure, so this is the PB dash, means the weight of the water resting on this inclined face and acting at the CG of area. The next forces which is acting on the gravity dam, that is the weight of dam. So, the weight of dam is major resulting force. It can be computed by taking the unit weight of concrete is as 24 kilonewton per cubic meter, or now we can say this is the 2.4 ton per cubic meter. So, the weight of the structures constructed on the dam should be estimated with fair amount of accuracy. So, these include the weight of gates, gantry on the top of dam, and weight of towers at the roadway level. So, the cross section of the dam may be divided into several triangles and rectangles, and the weight W1, W2, W3, etc. of each of these may be conveniently computed along with their line of action. So, the total weight W of the dam acts at the center of gravity of the section. So, W means the weight of each sections now is calculated by the weight density into the volume. So, now here is consider the 1 meter length of the dam. So, the weight is comes out the 2 point, or now you can see the weight density of the concrete multiplied by the area of this section into 1, and it will act at the CG of area. The third forces which is acting on the gravity dam, that is the uplift pressure. So, water has a tendency to seep through the pores and fissures of the foundation material. It also seeps through the joint between the body of dam and its foundation at the base, and through the pores of the material in the body of dam. So, the uplift pressure is defined as the upward pressure of water as it seeps through the body of dam or its foundation. So, uplift pressure force that will virtually reduce the downward weight of the body of the dam. So, according to the USBR recommendation, that is the United States Bureau of Reclamation, the uplift pressure intensity at the heel and the toe should be taken equal to their respective hydrostatic pressure and joined by a straight line in between, that will be shown in the figure. So, if suppose the water on upstream side is capital H, so then the uplift pressure intensity at the heel, that is the gamma W into H. And if suppose the tailwater is the H dash, so then the uplift pressure intensity, that is the gamma W into H dash. Or now here is also taken as a some uplift factor, that is the C, which will equal to 1 or less than 1. Or if suppose the value of so here this is comes out the uplift pressure intensity at upstream side is the C gamma W H, or at the downstream side, that is the C gamma W H dash. If suppose now consider the full uplift pressure, so the value of the C is taken as a 1. Or if suppose there is no water at upstream or downstream, so the value of the C is taken as 0. And the line joining. So now here the area of this uplift pressure diagram that will acting, this is the uplift force. The area of this diagram, that is known as the uplift force, and it is acting at the CG of area in upward direction and taking the moment about the toe. So then it will come out the clockwise, and all the clockwise moment, that will be the disturbing moment. So water pressure, if suppose acting clockwise, then it will be the disturbing. If suppose acting anti-clockwise, so that will be the resisting. The same, the weight of dam. So now the weight of the dam, taking the moment about this weight of the dam about the toe, it will come out the anti-clockwise. So that will gives the resisting moment. So uplift pressure can be controlled, because this uplift pressure, that will reduce the weight of the dam. So if the weight of the dam is reduced, then the stability of the dam that can be reduced. So it can be controlled by constructing cut-off wall under the upstream face, or by constructing some drainage gallery between the dam body and the foundation, or now you can say or providing by some pressure gouting the foundation. Suppose when the drainage gallery are provided, so to relieve this uplift pressure, so the recommended uplift pressure at the face of the gallery is equal to the hydrostatic pressure at toe, that is the gamma W H dash, plus 1/3 the difference of the hydrostatic pressure at heel and toe. So, by providing this drainage gully, then the 2/3 of the difference of the hydrostatic pressure at heel and toe, that should be the reduced. So, by providing this drainage gully, now the uplift pressure that can be reduced. The earthquake force, so this is the very important forces, and now always means considered as a disturbing forces. Okay. So, now that can be designed according to the IS 1893 1970. So, if an important dam is located in a region which is liable to get earthquake shocks, allowance is usually made for stresses caused by earthquake. So, an earthquake produced wave which are capable of shaking the earth upon which the dam is resting. So, in every possible direction, so the effect of an earthquake is to impart a momentary acceleration to earth crust in the direction in which the waves is travelling at that instant, while an earthquake wave may travel at any inclination through the foundation. So, it is usual to consider a vertical and horizontal acceleration acting separately. So, here is the two acceleration due to the earthquake either in horizontal direction and vertical direction. So, this is taken as a alpha h and alpha v. So, the value of these that will depends upon the place where this zone is located. So, the value of the alpha is taken as alpha h or alpha v is taken as the fraction of gravity. So, this is the point means 0.1 g or 0.2 g. So, now this value is vary from 0.1 to 0.2 times of g. So, actually means this earthquake forces means either it may be the increase the gravitational force or either it may be the means reduce the gravity force. So, then if suppose this is the reduce the gravity force, so now that will means any mass body mass that will comes in air, or if suppose now increase the gravitational force, so that will touch the earth surface. And now here these maps are shown the different zones of the earthquake zones. So, this is the green as well as some violet color that will be the dangerous, and now our Uttarakhand is comes in also in the dangerous zone. So, the first is the effect of vertical acceleration. So, if vertical acceleration may either act downward or upward. When it is acting in upward direction, so the foundation of the dam will be lifted upward and become closer to the body of dam, and thus the effective weight of dam will increase, and hence the stresses developed will be increased. When the vertical acceleration is acting downward, so the foundation shall try to move downward away from the dam body, thus reducing the effective weight and stability of the dam, and hence it is the worst case for the design. So, when the vertical acceleration acting downward and this foundation and the body of the dam, that will be separated to each other. So, then the stresses will reduce. So, inertia force, that is the mass into acceleration. So, this is the mass into acceleration. So, acceleration in vertical direction due to the earthquake, but the mass, that is the weight by gravity. So, this is the W by G into alpha B. So, this W means this is the total weight of dam. So, the total weight is acting means W, and the net effective weight of the dam due to the earthquake in vertical direction, this is the W minus W by G into alpha B. If suppose alpha B is taken as a kV into G, so this kV is the fraction of gravity adopted for the vertical acceleration or in vertical direction, such as this is the 0.1 to 0.2. So, then put the value of this kV. So, then here is comes out the W 1 minus kV. So, in other words, now we can say the vertical acceleration reduce the unit weight of dam material, and that would be taken as a 1 minus kV times of original unit weight. So, now if the providing the weight W, but that will considered as a 1 minus kV times of total weight of dam. Effect of earthquake in horizontal direction. So, effect of horizontal acceleration. So, horizontal acceleration may cause the two forces, that is the horizontal inertia force and hydrodynamic pressure. So, horizontal acceleration acting towards the reservoir causes a momentary increase the water pressure. So, as the foundation and dam accelerates towards the reservoir, and the water resist the movement due to its inertia. So, the extra pressure exerted by this process is known as the hydrodynamic pressure. So, thank you very much.